Good morning everyone. Today we are going to discuss the basic components of the Rankine cycle. Okay. The Rankine cycle is generally used in the steam thermal power plant. Okay. In this topic we are going to discuss the boiler, turbine and condenser and pump. Okay. So first we shall see the what are Rankine cycle and what are the main components of the Rankine cycle. Right? Okay. Okay. Slide. Okay, this is the general layout of the Rankine cycle. This is the general layout of the Rankine cycle. Okay, in the Rankine cycle, there are mainly basically four components. One is the boiler, second one is the turbine, okay, condenser or heat exchanger, and the compressor. Okay, these are the four basic components of the Rankine cycle. Okay, this is the TS diagram, this is the PV diagram. Okay, first we shall discuss the what is boiler. So what are these four components of Rankine cycle? Okay, generally in boiler, okay, in boiler what we will do? In boiler we will convert the water into steam, okay, by adding heat externally. Okay, that's why here we have mentioned QA. QA means nothing but we are supplying heat inside the boiler. Okay, where we will use Rankine cycle? We will use the Rankine cycle in steam thermal power plants. We will use the Rankine cycle in steam power plants. Right? Okay. Here, basically, in steam power plants, we will use this Rankine cycle. Okay. We will start the process. Process 1 to 2. Process 1 to 2. Here, in the compressor or the pump. Okay. Compressor. Generally, it is called as speed pump. Generally, it is called as speed pump. Okay, here in pump we are pumping the water from the condenser. Okay, whatever the water that is coming from the condenser, we are pumping with the help of this feed pump to the boiler. So 1 to 2 is the 1 to 2 process is the pumping process or compressor process. Okay, next 2 to 3. Okay, what is 2 to 3? It is the we are sending the fluid into the boiler. Okay, as we are sending the fluid inside the boiler, what will happen? This water is converted into the steam in the boiler. This water is converted into the steam inside the boiler. Okay, this here in the boiler, how it is converting into the steam? In boiler, the water is taking the heat from the external source and this water is getting heated and it is converted into the steam. Okay, so inlet condition of the boiler is the water, okay, and outlet condition of the boiler is the steam. This water is converted into the steam, okay, with the help of the external heat which is added in the boiler. And at the exit of the boiler, what is the condition of the fluid? The condition of the fluid is steam. Okay, 2 to 3 is the boiler. 2 to 3 is the boiler. In boiler, the water is converted into the steam with the help of external heat. Okay, this steam is directly sent into the turbine. Okay, in turbine, what we are doing? As we are sending the steam inside the turbine, okay, with the help of this steam, the turbine is rotated. Okay, as the steam is ejected on the turbine blades get rotated. Okay, this entire turbine blades are connected to one common shaft. Okay, this common shaft is coupled with the generator where we are getting the EMF. Okay, the common shaft is coupled to the generator where EMF is produced. So here what is the work we are obtaining? This is the work output. Okay, so inlet condition of the turbine is the steam. Okay, and in the turbine, what is the process? It is the expansion work. Okay, the steam is expanding in the turbine from 3 to 4. Okay, again at the exit of the turbine, okay, the fluid condition will be in the liquid plus vapor state. The fluid condition may be in the liquid plus vapor state. Okay, in turbine the steam is, okay, expanded from boiler pressure to up to condenser pressure. Okay, so directly the steam is expanded in the turbine from boiler pressure to the condenser pressure. So here the steam is directly entering to the condenser as it is expanding up to the condenser pressure. Okay, again from the condenser, in condenser, okay, liquid plus vapor mixture is converted back to the liquid, So what is the process occurring from 4 to 1, that is in condenser? It is the heat rejection process. Okay, it is a heat rejection process. So here there are, in Rankine cycle there are 4 processes. Okay, 1 to 2 is the pumping. Okay, pumping. 2 to 3 is the heat addition. 3 to 4 is the expansion. 4 to 1 is the heat rejection. Okay, that is Q out. Here Q in. So totally here we are getting 2 heat. Okay, one is the heat addition, one is the heat rejection, and one is the compression, one is the expansion. So if you want to represent this in terms of diagram, that is in TS diagram. This is TS diagram. Okay, here if you can see here from point 1 to point 2, what is the process? Point 1 to point 2, that is the, okay, what see here is the diagram layout. 1 to 2 is the isentropic compression. 1 to 2 is the isentropic compression. Okay, from 2 to 3 is the okay, addition, heat addition, constant pressure heat addition. 2 to 3 is the constant pressure heat addition in the boiler, and 3 to 4 is the isentropic expansion in the turbine. 4 to 1 is the condenser. Okay, this is the TS diagram. And similarly PV diagram, if you see the PV diagram, 1 to 2 is the isentropic compression, 2 to 3 is the heat addition in the boiler, constant pressure heat addition in the boiler. 3 to 4 is the isentropic expansion in the turbine. 4 to 1 is the heat rejection in the condenser. Okay, this is the general layout. We will discuss the, in next slide we will discuss the what is the actual layout. Okay, actual layout. Okay, as I have told in the Rankine cycle, that is the Rankine cycle, this is the modified Rankine cycle. Okay, actually in the modified Rankine cycle you can see this is the TS diagram. Okay, initially what is the, from where we are starting the process? 1 to 2. Okay, 1 to 2 is the compressor process or feed pump process. Okay, where we are getting work input. Okay, in order to run the feed pump, what we are doing, we are, okay, giving the input to the compressor or pump. As we are giving input to the pump is pumping the fluid from the condenser to the boiler. Okay, this process is generally represented from 1 to 2. Okay, we'll see the TS diagram. Okay, 1 to 2. Initially at point 1 the liquid state will be there, the fluid state will be liquid. The fluid state will be in the form of liquid. So if you go to the TS diagram, you can see this is the liquid vapor flow. Okay, left side one is the saturated liquid one, right side one is the saturated vapor line. Okay, left side curve is left side line, this line is the saturated liquid line, the right side line is the saturated vapor line. Okay, we start from here the process. Point 1, that is the inlet condition of the feed pump. Point 1 is the inlet condition of the feed pump. Okay, what is the fluid condition at point 1? The fluid condition is liquid or saturated liquid. From point 1, okay, the point 1 is at condenser pressure and in the saturated liquid state. Okay, from this point 1 to point 2, see here, point 1 to point 2. Okay, the feed pump or compressor is pumping the fluid or compressing the fluid from boiler pressure, that is point 1 pressure to point 2 pressure, with the help of the compressor or feed pump. Okay, you can see in the layout 1 to 2 is the feed pump or compressor. Okay, with the help of compressor or feed pump we are pumping the fluid from low pressure, that is condenser pressure, to high pressure, that is the boiler pressure. Okay, isentropically. Okay, so this fluid is pumping isentropically from boiler pressure, from condenser pressure to the boiler pressure. Okay, this is process 1 to 2, that is represented in TS diagram. Next, process 2 to 3. Process 2 to 3. Okay, process 2 to 3 is the boiler. Process 2 to 3 is the boiler. Okay, in boiler what we are doing? In boiler we are adding the heat at constant pressure. Okay, if you observe, this 2 to 3 is the constant pressure. This is a constant pressure line in the TS diagram. This is a constant pressure line. In the boiler, okay, we are adding heat at constant pressure. So initially the liquid is converted. This liquid is by adding heat in the boiler or by taking the heat in the boiler, it is converted. First, initially the temperature of the fluid will get increased. Okay, if increase further heat, what will happen? This water will convert it into the steam slowly as move from 2 to 3. Okay, and initially the steam formation will start. Okay, and at this point, okay, the steam will be saturated state. At this point, okay, the steam is in the saturated state, that is complete vapor state or gas state. Okay, if you further add heat at constant pressure, what will happen? This saturated steam is converted into the superheated steam at point 3. So process 2 3 is the constant pressure heat addition. Process 2 to 3 is the constant pressure heat addition. Right? Okay, in the boiler 2 to 3 is the constant pressure heat addition in the boiler. Okay, and at the inlet of the boiler the fluid is in the liquid state, and at the exit of the boiler the fluid is in the superheated state by taking the heat in the boiler. Okay, so here heat is supplied at constant pressure in the boiler. We get point 3 to 4. If you observe this layout, 3 to 4 is the turbine. What we are doing in the turbine? In the turbine, isentropic expansion is taking place. Okay, 3 to 4. Okay, at the inlet of the turbine, the fluid state is superheated state. Okay, this superheated steam is entering into the turbine and it is expanding isentropically from 3 to 4. So here work is said to be done from 3 to 4. Okay, this is isentropic expansion. Again, from point 4 to point 1. Okay, here if you observe, from 3 to 4 in the turbine, the superheated steam is expanding from boiler pressure to the condenser pressure. Again, from 4 to 1 is the condenser. Okay, point 4 is the inlet of the condenser or exit of the turbine. From point 4 to point 1, okay, heat is getting rejected to the cooling water. Okay, this liquid plus vapor mixture, which is exit of the turbine or inlet of the condenser, okay, is sent into the in the condenser. What we are doing? We are ejecting the heat or rejecting the heat at constant pressure. So in condenser, this liquid plus vapor mixture is converted back to the saturated liquid. So here totally how many two constant pressure processes are there and 2 isentropic processes are there. 1 to 2 is the isentropic pumping 2 to 3 is the constant pressure heat addition, that is in the boiler. 3 to 4 isentropic expansion in the turbine. 4 to 1 constant pressure heat addition, sorry, heat rejection. 4 to 1 is the constant pressure heat rejection. 2 to 3 is the constant pressure heat addition. Okay, this is the general layout of the Rankine cycle, and we will see the efficiency. Okay, efficiency. What is the general formula of efficiency? General formula of efficiency is output by input, and here there we have to consider certain assumptions. What is that process is? Okay, here we are considering steady flow in process and no generation, and neglecting kinetic energy and potential energy for all 4 devices. Okay, we are neglecting all the kinetic energies and potential energy and no generation. Okay, so here from each process what is the work we will see. 1 to 2 is the pumper. Okay, 1 to 2 is the pump or compressor. Okay, W pump equal to, what is the enthalpy? Is H2 or HF2, H2 minus H1, that is a pumper. Or we can write a specific volume into, okay, boiler pressure minus condenser pressure. Next 2 to 3 is the boiler. Okay, so what is the here, how much amount of heat is added from 2 to 3 means highest enthalpy H3 minus H2, that is the fluid enthalpy which is coming in the boiler, H3 minus H2. Next turbine is 3 to 4. So what we are getting here? We are getting work output. Here 1 to 2 is the work input, 2 to 3 is here we are adding heat. So 3 to 4, what is the work output? Is function work we are getting, that is H3 minus H4. Again from 4 to 1 condenser. Here we are rejecting the heat. So how much amount of heat is rejected means H4 minus H1. Okay, so thermal efficiency is net work done by heat input. Okay, net work done, what is the net work done? Okay, work output by work, that is turbine work by pump work by where we are adding heat. We are adding heat in the boiler, H3 minus H2. Okay, this is the efficiency. Efficiency equal to work done by heat supply. Okay, work done is equal to work net equal to pumper, thus turbine work minus pumper. Work minus pumper by heat supply. Where we are supplying heat? We are supplying heat in the boiler. Okay, this is the general Rankine cycle efficiency. Okay, next slide. Okay, that is the general Rankine cycle. Okay, in order to increase the efficiency of the Rankine cycle, we are going to discuss few methods. Okay, in order to increase the thermal efficiency, okay, what we need to do is, first point, see here, in order to enhance the efficiency or enhance the thermal efficiency, what are the things to be done is, okay, first point is lowering the condenser pressure. Okay, by lowering the condenser pressure we can increase the efficiency. Next one is the superheating the steam to a higher temperature. Okay, superheating the steam to the higher pressure. Next, third one is the increasing the boiler pressure. Okay, in order to increase the thermal efficiency, what things we can do is, okay, thermal efficiency can be improved by manipulating temperatures or pressures according to the various components. In that, how we can do means, first thing is lowering the condenser pressure. By lowering the condenser pressure we can improve the thermal efficiency. Second thing is the superheating the steam to a high temperature before entering into the turbine. Third one is the increasing the boiler pressure. Okay, these are mainly generally 3 points, okay, that you need to do. Okay, how we can do this? Generally there are two methods are there. Generally 4 methods are reheating, okay, regenerative for feed water heating, okay, binary vapor cycle, binary vapor. Next is the by water extraction method. Okay, first we will see each one by one method. First is the reheating method. First method is the reheating method. Okay, in general Rankine cycle, what are the components are there means, okay, condenser is there, heat pump is there, boiler is there, turbine is there. But in reheat cycle, what we are doing means, reheat cycle, what we are doing means, here we are initially the steam. We will see from process 1 to 2. Okay, in reheat cycle, what we are doing means, here we are reheating the steam from the turbine. Okay, and how we are reheating? We are reheating by extracting the steam from the turbine, okay, and sending it to the boiler. In the boiler, okay, heated to the extracted steam, and again it is sent to the turbine. Again here we are getting the expansion valve. Okay, see, we will see the reheat cycle in detail. Okay, here process 1 to 2, that is the pump. 1 to 2 is the pump. Here in pump, heat pump, what it does, whatever the water that is coming from the condenser, it is pumping from 1 to 2. Okay, next 2 to 3. 2 to 3 is the boiler. 2 to 3 is the boiler. Okay, 2 to 3 is the boiler. In boiler, okay, we are adding heat at constant pressure, so this water is converted into a steam, and this steam is entering into the high pressure turbine. High pressure turbine. In high pressure turbine, the steam is expanded isentropically from 3 to 4. Okay, in high pressure turbine, steam is expanding isentropically. Okay, at the exit of the high pressure turbine, the steam is extracted and sent into the boiler. The steam is extracted at the exit of the high pressure turbine, and it is sent into the boiler. Again, after reheating this steam up to certain temperature, okay, and note that here the heat is added at constant pressure again in the boiler. Okay, the steam is extracted from the high pressure turbine and it is into the boiler, where it is heated at constant pressure to certain temperature. Okay, again it is resent into the low pressure turbine. Again here isentropic expansion is done in the low pressure turbine from 0.5 to 0.6. Okay, here the steam is sent into the condenser turbine. In low pressure turbine, isentropic expansion is done from this pressure to condenser pressure. This pressure to the condenser pressure. Okay, in condenser, the liquid plus vapor mixture is converted back to the liquid by rejecting the heat. Okay, so finally what we can tell here. Okay, here if you see this TS diagram, 2 to 3 is the boiler. Again from 3 to 4 is the high pressure isentropic expansion mode. At 0.4 we are extracting the steam from high pressure turbine at certain pressure, and at 0.4 the steam is extracted and it is resent into the boiler, and it is heated at constant pressure up to temperature of T5. Again at this T5 temperature, the steam is entering into the low pressure turbine and it is expanded from this pressure to the condenser pressure. Again in condenser, this liquid plus vapor mixture is converted back to the liquid. Again the process cycle is repeated. Okay, in next class we will see in detail what is the working and how we derive the efficiency of the reheat cycle.